All right, so let's go ahead and continue working on our software rendered game, right? So it doesn't look like anything, right? So in fact, it looks like shit, I think. It currently looks like shit. So, oh yeah, so there's a bunch of test things in here. So there's a huge room, which is a huge cube. I also added sort of like an indication of a player, and there's like a one single item. So this cube, by the way, is just like a huge ass cube with winding order of the faces inverted, so it looks like inside out. Right. So in fact, I think I can even demonstrate you. So if I go into the game, I'm pretty sure there's a place model, and where do we call place model? So here's a Panger item. So here is the starting room. And so there's a parameter in here is the flip a winding order. All right, so I'm flipping the winding order. If I don't flip the winding order, so it's going to look like you're not gonna see the cube. Right, so you'll have to kind of go, yeah, something like this. So this is how the cube is going to look like. So introduce the parameter into the model player that basically inverts the winding order. So then when the backface culling is enabled, you can actually see inside of the cube. Though if I specifically disable backface culling, you will be able to see things, right? So, but it's just like kind of weird. It's like there's no optimization. Right, so you probably want to have this kind. Like, you can even see how FPS changes when I enable or disable backface culling, right? So it's kind of quickly. But anyway, so that's not really the topic of today's stream. That's not really the topic of today's stream. The topic of today's stream, I think I even have a task for the topic of today's stream. I have a small issue tracker in here. I first need to build it though. Tasks, see. All right, so I have a small issue tracker. So yeah, color support in asset models. So I have a small issue tracker. Like this is just an experiment in here. It's just like I have a task, and each individual task is a separate folder, right? As you can see, I have a bunch of folders in here, and the main file in here is a task, and it's a markdown file. And here you have a title and a bunch of sort of properties and parameters. And as I work on the task, I may put some comments in here and so on and so forth. And the reason, by the way, it is a folder is because sometimes I may encounter a bug and I want to put like maybe a screenshot in there, right? So, and I need a place to put a screenshot in there. So this is just like a folder. I think I even have an explanation in here. Yeah. So this is an improvised task tracker because I do need something more powerful than just plain to-dos in a source code. Yet I don't want to install a full-blown issue tracker system. So that's how it works. And I have a simple program that just like parses things and sorts them for me, and then I can just like basically jump to a specific task, something like that. So yeah, so that's basically what it is, and it also allows me to create new issues, right? So for example, I can say hello, and as you can see, it created a new issue for me, right? So it set the priority, I can set the priority 100, it set the status, and just created a folder and stuff like that. I can take a look at what this thing is, and here is the hello. So yeah, maybe one day I'm going to release it as a separate project, but this is, since it's an experiment, I sort of like don't even know if it's a good experiment or not. So it just like sits in that repo. It just sits in that repo. So essentially somebody on Discord actually suggested to maybe develop a game in this specific style. I would open the message on Discord. But unfortunately I disabled VPN, so there's no Discord for me right now. So basically use these kind of assets or do all of that stuff in this specific style, which is kind of a cool style, don't you think? I think this is a pretty cool style. Right, so, and it has a bunch of models in here. So let's actually download them. Right, so it's going to be wget. I'm going to put it in there. Cozy style, yeah, it's a pretty cool style. So, and obviously I want to probably put that stuff in here, and for the people on YouTube, I'm gonna put this stuff in here as well. So here it is. I hope it is not, okay, so this is in fact a zip bomb. So let's create a separate folder. I don't remember how to make zip utility to create a separate folder, but I'm too lazy to actually learn it right now. A little bit lazy to actually learn it right now. So, and the problem is that our current system does not support colors of the objects, of different kinds of objects. So, yeah, here are different OBJ files, right? So they are using Windows new lines, absolutely disgusting, but I mean, it is what it is. And I suppose the colors are set through MTL files, and MTL files are sort of these material files, right? So I think that's what MTL stands for. All right, so let me take a look. Can I essentially open them with a Blender, right? So this is a very interesting question. So I do have a Blender somewhere here. So here's the Blender. Okay, so I'm gonna just run it like that. And there should be a way to maybe export an BabaG file, OBJ file. Yeah, there we go. So I wonder if I can somehow copy paste this whole path. This is a huge ass path, by the way. This is a huge ass path, and hopefully, yeah. All right, so we're gonna open, by the way. So shovel, how about opening a shovel? Did I manage to open? When I clicked it, it was actually red, and it said something and I didn't read it. So I'll have to export it again. Import it, not export it, I'm sorry, import it. Wait, did it modify it? Oh shit. No, it didn't really modify it. So, well, shovel. Yeah, it modified it, I think. I fucked it up, so it turned it into confused import. Honestly, I always confuse import and export. It's kind of difficult for me to distinguish them quite often. Okay, so we'll just try to unpack all of that stuff one more time, right? So, oh my god. All right, so let's unpack it one more time. One more time. So it's an import, and I'm gonna just do BabaG file, and of course I'll have to grab that path one more time. It didn't remember that previous path, so but maybe it could be in the history, but it wasn't in history. So okay, OBJ files. So let's open a shovel, right? So import wave OBJ. Okay. I think I see something, so I suppose I have to. Yeah, there you go. So it doesn't display the materials or anything like that. There should be some sort of a way to display how fully. Yeah, there you go. I think this is how it looks like. So, and instead of colors, it uses this weird color map, which I think is located somewhere in the texture. So they all refer to the color map. So, and I suppose this is just like a texture. Right, so they use that as a texture. So our system does not support any of that stuff. Right, so our system does not support any of that stuff, so we'll have to add support for that somehow. So how our system even works right now? So let's actually see. So let's grab the shovel. Right, so this is going to grab the shovel, and I have to put it into the assets folder, right? So I have an OBJ folder in here, so this is going to be assets. So I would like to maybe create a separate folder for these kind of assets in here, right? So it's just like from the same set. So, and this is going to be shovel, and I'm going to copy paste this entire thing, and just in case, I think I'm going to copy paste the textures too. But we don't support MTL files at all, so it's not going to refer to any of these things, but I mean, we still need all that stuff. So the way it works, we don't load any of these assets at runtime. We actually pack them at compile time. Right. So, and that is has a very interesting advantage in the sense that during the runtime, the game doesn't need any machinery to parse any of the assets at all. We sort of pre-parse all of the assets for the game, and we append them into this binary blob, and we give it to the game. So the game just takes this binary blob, which is currently 1.2 megabytes, and just loads it and maps it into the memory, and takes a pointer to it, and then it just points into a collection of assets that it can directly use. It doesn't need to fiddle with different format or anything like that. Everything is pre-parsed, already adjusted, and so on and so forth. Right, so, and because of that, during the runtime, it doesn't need additional libraries or anything like that, because everything is already ready in the memory. So maybe we're gonna make modifications to the system, right? So I was planning to maybe add a compression, global compression on this entire blob. right? Because if you're using, like, for example, PNGs, the PNG has a built-in compression. As soon as you pre-parse the PNG, you get rid of the compression. So we can put it back, but on the whole blob somehow. We'll see. Maybe I'm going to do a stream on that. But anyway, so, and also it automatically generates like a file which gives you the asset table, which is basically this structure, right? So this is basically all of the assets that we have, right? So, and the program responsible for all of that is a separate program that first compiled during build step and then run, and it generates the blob and it generates the structure, and only then the main game is compiled. So this is the two steps. First, we pack the assets, then we build the game, and we link with this kind of code that was generated in here. Exploring compression algorithm could be interesting. Yeah, so I was thinking about maybe even just see if slapping RLE is going to just reduce the size of the blob, right? So is it called RLE? Yeah, run length encoding. So because it's the dumbest and simplest algorithm, like a compression algorithm, and I wonder if just doing that will already compress the assets. But honestly, as of right now, it's 1.2 megabytes, right? So at 1.2 megabytes, I don't think you need that much of a compression right now. So we'll see as the game progresses, as the game development progresses, the assets blob is going to grow, and we'll see to which point is going to grow. Like, I mean, even if it's going to become 1 gigabyte, is it too much? Well, I mean, for the game I plan to develop, it is kind of too much. Like 100 megabyte, right? So uncompressed, it's kind of fine. You can very easily, within like a millisecond, load 100 megabytes into memory, right? So you don't need compression in here. Just put all into memory. Who needs compression? Exactly. That's exactly my thought, right? So because it's 2025, all of that compression for the game I'm trying to develop were needed because the computers were not as powerful as they are today, right? So I'm kind of like using old techniques for game development in here, but I'm doing that in a modern setting. So a lot of the things that people did in the past, you can revise them and just not do them because you can just use a more powerful computer. People in the past couldn't use the more powerful computer. We can. But anyway, so what we need to do, we need to go into the assets, and there is like a global static array of all of the assets and their description and how you have to pack them and so on and so forth. So here it is. And so here's how we pack the models, right? So essentially what you have to do, you have to create a new element in here. So in the kind we're going to have is an asset model, right? So here's the asset model. Then you have to provide the input path, and let's actually go. So it has to be in the asset folder, assets folder. So then we're gonna have OBJs, and so let me go in here. So here's the OBJs, and here is this set of babajis, and let's take the shovel.obj. All right, so, and then you have to provide the name, and the name, by the way, is going to be the name in that structure, in the, basically the field in that structure. So let me actually see what we have in here. So yeah, so this field, right? So, and once you define it, you'll be able to access that assets through that name. So let's go ahead and do that. So we already added that to the field. So the only thing that's left is to just build this entire thing. And it doesn't build because shovel has a G. And suppose this is a group, right? So if I take a look, okay, so there is several of them. There's several G's. So OBJ format, I think in Wikipedia there was some explanation of this thing. So wavefront OBJ file. So let me actually put that in the description, right? So it's one of the things we're going to be using in here. Okay, so here are different directives of the OBJ format. OBJ, called OBJ, but it's OBJ. Yeah, there you go. So you have objects, and then within the objects you have groups, and I'm not really sure what the fuck is group. Do they even talk about groups? Named objects and polygon groups are specified with the following tag. Smooth shading across polygons is enabled by smoothing groups. Okay, I kind of remember smoothing groups, I think. So let me go into the assets in here somewhere, and in here, there was a smooth, yes, smooth groups are not supported right now, ignoring them. So this is how we deal with them. Maybe we're gonna deal with the groups a similar way. I suppose OBJ kind of define a scope, right? So because if you take a look at how all of that is done, right? So for example, you're loading material library, right? You're just loading material library. Then you create a group, and we can find another group in here. And then we use directive use MTL color map. And I suppose this color map is defined within this, yeah, there you go. Here is a material called color map. And then within this group, they're using that color material. So I suspect that these groups define the scope where a particular material sort of has an effect. Do I understand it correctly? Because I know almost nothing about OBJ format, and I'm just going off of how the format looks like, because it feels like group just defines a scope, right? So, and then you use a particular material, and material is applied to that specific scope. So this is how OBJ works. Okay, so in that case, we're gonna just ignore the group as well. So what I'm gonna do in here is just I'm gonna say, all right, groups are not supported right now, ignoring them, right? So because we just want to load the polygons, we want to load the faces. And let's just go ahead and try to build the whole thing in here. So we'll do it. Okay, so that was actually super fast, and it does say all right. Okay, cool. And if we just try to run the game, nothing is going to change except for the fact that now in the table in here we have a shovel. There we go. That's the shovel, and you can actually access it. So shut the fuck up. All right. Anyways, let's let's continue. Excuse me. So there is a panger item. Let's actually replace the panger item with something else. Right. So here is the asset, the global variable. And yeah, let's replace it with shovel, right? So this is a shovel now, so should be able to just run the whole thing. And do we have a shovel? It's a tiny shovel. It's so small. This is probably because I'm scaling it. Oh, it's so cute. Look at that. It's a tiny shovel. It's a tiny fucking shovel. Okay. Can I make it bigger? Okay, so the scaling. Okay, so here is the transformation. Yeah, so, and we just apply different transformation. When I do place model, right, so here is the OPT and stuff like that, and I can supply the transformation matrix to transform each individual sort of vertex and stuff like that. And what I'm doing in here, I'm actually scaling it, right? So as you can see, I'm just setting diagonal to 0.5. So I suppose maybe I can factor out the scale into something like this, right? So this is going to be something like that. So this is the scale, and let's just set it to 1, right? So why does it have to be this way? It doesn't really have to be this way. Could be just an identity matrix. So look at that. So that's yeah, that's the shovel, right? So I can just look at that, and it even has a lighting. So the rendering is a little bit weird. It's just like on the edges, but we can say that this is a, yeah. Look at that. So, and this is a completely software rendered engine, right? So we're not using OpenGL or anything like that. We also parse OBJ files ourselves, right? So this entire thing is just basically like developed from scratch. This is actually kind of amazing. So talking about jaggedness, no, not really. Just a second. It's not really jaggedness, but maybe I can capture for, yeah, so there is these sort of like gaps, but I think I have an issue for that specifically to look into. I don't think I want to focus on it right now. Yeah. So, and usually with OpenGL this doesn't happen. It's just like some sort of an imprecision going on here for sure. Some sort of imprecision, especially. Yeah. We'll figure it out. I can also put a specula in here, so here is a little bit of a specula. It's a shiny shovel. So where's the, how do I do diffuse? I forgot how to do diffuse. Diffuse lighting is E. Okay, so this is without any diffuse, and this is without any fog. Right, so here's the diffuse, fog, and specular, and that's different effects that you can have in here. Look at the FPS when I enable this menu. Like actually, it depends. Sometimes, yeah. So the reason why this menu slows everything down is because I compute this outline at runtime. The original. I think I implemented it just today, so it doesn't look like shit. Right. So and it computes the outline at runtime. So I think I need to actually bake it. Right. So I need to first bake it, and I do have like a asset packing step. So essentially I can just like put it in there. I can just put it in there. You can just render the text twice to do the shadow, but outline is also good. Shadow, I did shadow, it looked like shit. And I remember Godot had same issue not long ago. I see. So the one way to solve it is just to pre-render it. It's to just pre-render it. Okay, so what we need to do, we need to actually start parsing the colors, right? So we have asset types in here, and so here is the model asset, and here we have a vertices, right? Then we have a texture coordinates, and we have normals, and we have faces. And I'm not quite sure how exactly we're going to do all that stuff and how exactly this specific model even does that. So let me just reverse engineer the whole thing in here. Kind of reverse engineer, right? So because I'm too lazy to read the computation. I hope that pisses off a lot of people, by the way. So here is the vertices, all right, so that's understandable. So we also have vertex normals, right? So they are important for light, I suppose. And this is the texture coordinates, I suppose, right? So these are the texture coordinates. And I feel like these texture coordinates might be from this color map, right? So they might be from this color map. And then here are the faces. And I remember that faces, they just basically tell you, okay, use these vertices, then some of the texture map. So it tries to reuse texture map, and then it tried to reuse some of these things. So I'm not 100% sure. So what should I do? I feel like vertex normal texture map. Yeah, I have this weird idea on how to test it out. So what if I basically bake this color map into the assets? What if we try to do that? So let's give it a try. So then I have an access to this map during runtime and stuff like that. So somewhere src build. So this is a src build, and where is all of that stuff? And it's going to be basically hard coding, right? So, but I don't really like hard coding things. So if my hypothesis is correct, we'll try to make it less hard codish, right? So we'll have to make it more general in here. So kind is asset image, right? So here's the asset image, and here is the so this is the input path, right? So this is the input path name. So this is a shovel. So let's call it a texture, right? So this is sort of like a current texture that we're dealing with. All right, let me try to build the whole thing. And I just fucked something up because I forgot a comma. So what the fuck are you even? Oh yeah, so because this is a folder. So I have to do something like this: Kenny graveyard texture color map png. All right, so do we have it here? So here's the color map png. Cool. So in a table there should be a texture. So here is the image texture. So here it is. So what I want to try to do, I want to try to maybe add I can add a parameter to the placer of the model. So here are different parameters, like one of them is flip winding order and stuff like that. And here I can put something like color map, right? So color map. And by the way, I think in that vein I can call it a color map. Let's call it a color map. I think that will be better. So here's the color map, and if it's set to true, place model is going to ignore the color that you specified. So because as of right now, when you place a model, you actually tell what color do you want it to use. What color do you want it to use, right? And essentially it just does something like this. Furthermore, maybe it's not going to be color map as Boolean. It could be actually something like image asset, a pointer to an image asset, and by default it's going to be null. But if you set it to something, it's going to use that as a this is a cool idea. I kind of like that, actually. I kind of like that. So yes, and now here is how we're using the colors in here, right? So that's how we're using the colors. But now if I go and say something like if OPT color map is actually not not null, we have to take the texture coordinates of the face. We're taking the texture coordinates of the face. So let's try to find them. So there were asset types, and here is the face, right? So where is the definition of the face? Okay, so here is VT, right? So here is VT, so that means model, right? So here is the model, here is the faces, right? And within the face, we're taking its vertices like this, right? So that means here we have to do something like VT0, right? So here's VT0, 1, and 2. And this is a vertex coordinate. So if they're using color map as sort of like a texture, that means this vertex coordinate is going to be pointing within the color map at the cell of a specific color. So interestingly, it's not even a color map, right? So it also uses like a gradients in here. So this entire style might look like flat colors, but in reality it is not really flat colors if you think about it. It's really not flat colors. It's more gradients and stuff like that. So if we just take we can actually just apply the colors of corresponding things in here. I think I saw a post about the gradient. It's to add a little bit of fake lighting. Yeah. So that makes sense, actually. That makes sense. So what I'm thinking is that, so here's the ABC, and these are the vertices, right? So these are the vertices. I would like to maybe call them VA, VB, and VC. Right, so because this is that, so then later I could do something like VT, right? So because depending on the winding order, right, we'll have to like define them in different orders, right? So that's what's going on here essentially. Okay, so let me try to do something like this. Right, so this is VT, and this is VT, and this one is also VT. So this is VT, cool. So I'll probably also have to update this kind of stuff. So this is just V and V in here. Okay, if it's a color map, what we have to do is textures, not really faces even, but literally textures, right? So yeah, they're called text chords, and they're actually two-dimensional vectors, right? So these are text chords. All right, so text chords, not count, but just text chords. VTA, VTB, VTC. Cool. So if you have a color map, right, so you should be able to get a pointer in here, but you have to keep in mind that this thing is actually normalized. So the texture coordinates are not within the coordinate system of the texture, not on the pixel coordinates. They are normalized, which means that they're from 0 to 1, right? So x is from 0 to 1 and 0 to 1. So you have to remap them correspondingly, right? So you have to remap them. And which means, let me think. Let me maybe try to take this kind of thing. So I already kind of called them VT. Oh, this is not what I want. I want to call just T. This 1, 2, 3. Right. So I have to divide them by the size of the texture. Right, and since the color map is an image asset, right? So this is an image asset. What I have to do, I have to take its size as a vector. So image asset. I do have width and height, which is good, right? So that means I can do opt color map. I can take its width, then I can take its height, and maybe turn that into vector, right? So let's actually make it a floating point vector. So this is basically the size, right? This is our size. And in here, we have to divide one by another. We can do F2, divide this one. Actually not divide, multiply it, I'm sorry. So we're multiplying it. So since it's normalized, I can map it to my texture by simply multiplying it. And I want to do that for each individual thing in here. So I also don't take into account like OpenGL coordinates and not OpenGL coordinates and stuff like that, but I mean, maybe it doesn't really matter that much. So, and here are the coordinates in here. And a funny thing is that once I get these coordinates, right? So once I get these coordinates, I can essentially just take a pixel from that specific map and just use that as a color of the vertex. So this is what we can do actually, right? So just use it as a color of the vertex. I think that will kind of approximate it to how the model is supposed to look like. I'm not sure if it will use the gradients because we don't really right now interpolate between the colors, right? So there we go. So here is the rendering of this entire thing, and I explicitly disabled interpolation between the colors because it's slow and it's unclear if we need it if we introduce texture. Well, I mean, yeah, so that's kind of an interesting thing because this is technically a texture, but also we're doing color interpolation. But yeah, one thing we may try at some point is just to enable the color interpolation and just see how it goes. So the way it currently works, when you try to render a triangle vertices have colors associated with them. So, and a render is supposed to like smoothly interpolate between them, creating a gradient, you know, the rainbow triangle and stuff like that. I disable that. It takes the color of the first vertex and colors the entire triangle with that color, right? So because that way you don't have to do this expensive operation, right? So all of this interpolation and stuff like that, and it's just like, it's not really needed anyway. We can just like switch it on and see maybe it will improve the look and stuff like that, but so let's actually finish what we're doing here. So I wonder how the animations are usually stored using OBG. Okay, so OBG, maybe wavefront, OBG animations. Let's Google that. 10 FPS incoming. Okay. Clanker is not saying. Oh, by the way, so DuckDuckGo recently actually shut the fuck up the clanker, right? So I think you have to. Yeah, you have to explicitly ask the clanker to generate the response, which is actually much better, I think. Right, so they didn't try to shove the clanker in your face as, for example, Google tried to do that, right? So it's just like the button, ask the clanker, right? There's also no AI DuckDuckGo, nice. So the clanker button. Anyway, so does it have any animation? So the advanced visualizer animation package. So add the geometry formats. Ooh. So OBG files support higher order surfaces using several different kinds of interpolation, such as Taylor and B-splines. We know how to render B-splines, by the way. Although support for these features in third-party file readers is far from universal. OBG files also do not support mesh hierarchies or any kind of animation or deformation. So to answer your question, that's the neat part. They don't, right? So they don't store any animations or anything like that. So yeah, we'll see how we're going to be doing animations. So what I'm thinking about is to do skeletal animation, right? So, and for skeletal animations, we'll probably need to use a different format then, right? So I remember Jonathan Blow had a cool video explaining skeletal animations and stuff like that. Right, so he talked about like just like interpolating the positions of skeleton. How do you say that in English? I forgot. And I need to rewatch that video, right? So because I remember that was kind of good. I think it was a video of him refactoring something about his animation format or something like that. GLTF. I actually don't care about specific format. So whatever Blender can export, I will just parse that. So, so specific formats is just like details, right? So I don't really care about them. Anyways, so as of right now, so here is the color. I might as well actually do something like C1, C2, and C3. And this is going to be color C1. And as of right now, I'm going to just set all of them to the same color. But if you specify the color map, we can just go ahead and change them. And by the way, since I'm going to be accessing the pixels, I should probably not use floats. I should use integers. All of these things should be integers, right? But that means I'll have to convert them into something somehow. So maybe we can do conversion. So it's going to be v2. I want to create the integer one, but I'm creating it from the floating point one. So this is how the conversion is done. All right, so and they are integers now. And what should I be able to do? I should be able to take the color map and I should be able to take the pixels. So let me, here they are, here are the pixels. And then I do VT1, I take the row, multiply by the color map's width, right? So that's the width, and I've set it by the specific column. And that's the new color we're dealing with. That's the new color. We have to repeat that for the rest of them. So this is going to be 1, 2, and this one is going to be 2, 3. There we go. So that kind of sets the colors accordingly. And one problem could arise in here if, for example, texture coordinates somewhere are equal to 1. So that will make it literally equal to the size, to the width and height, which is kind of overflows the buffer. So let me take a look at the shovel OBG. So there was a VT, and I didn't see any of the VTs being equal to 1, and I'm not sure if they can be equal to 1. So that's kind of an interesting question. But yeah, we probably want to do some sort of assertion here, right? So we want to assert that this thing is at least when I do size t is less or equal to OPT color map height, the same for the X, and I'm explicitly casting it to size t because it's unsized. So if unsigned, because if this thing is negative, casting it to unsigned will make it a huge number, which will overflow the width. Very likely will overflow the width. That's kind of the idea in here at least. Right, so in here we can kind of do a similar thing in here. So I still want to double check the boundaries. Even though it will slow down the algorithm, it will make it safe. It will make it memory safe, chat. It's a memory safe code. Anyways, so let's take a look at the rest of the errors in here. So here is is it called width? Yeah. So it has to be, okay. Can I do OPT color map dot and replace it with OPT color map arrow? Right, so that's a lot of changes, and I'm gonna just accept all of that stuff. Okay, so here is another error in here. Oh yeah, this one is interesting because these pixels are uint32s. Why the fuck are they uint32s? Can I, by the way, just literally replace that with a color? Because they have the same size, honestly. They do have the same size. And in fact, static assert, I can basically statically assert that the size of color is equal to size of uint32t or something like that. So, yeah. What we're gonna say in here? Ooh, I don't know what to say. Just expected format is a GBA32 expected pixel format. All right, so that will probably, you know, not compile in some of the places. Look at that, it actually compiles at present. But I mean, I'm glad that I still ask this kind of thing. So the packer didn't give a shit about any specific. Yeah, that's kind of funny actually. That's kind of funny. So, and that will actually work, I suppose. And what do we use images for? We don't even use images for anything, don't we? So we only use them for cursor. So that means an overlay, when I place an image, yeah. Aha, this one is interesting, isn't it? Aha, look at that, look at that. So, yeah, I used to directly take in uint32 and then punning it to point it to the color and then extracting. I don't have to do that anymore. Right, so I don't have to do this kind of stuff anymore because they are colors now. But anyway, whatever. So this is just like this kind of stuff. And that should already maybe color the shovel, but it won't because you have to explicitly set the color map. We didn't set the color map. Right, so here's le shovel, and yeah, so let's go ahead and just do this thing like that. Where is the le shovel? So in here, I set the color map to assets color map. Right, so, and that should give me potentially the color map. Yep, that kind of worked. At least on the handle. Is that how the handle's supposed to look like? That is fascinating, actually. It's not really budgeting. I wouldn't say it is a budgeting, but it is doing something. Because of grouping. So there's a little bit of a grouping in here. A little bit of a grouping. But I don't remember. All right. So let me think. So it's probably doesn't work the way I think it works. But that was kind of the point of checking it out, right? So it's kind of the point. So here's the group, and we don't even set anything to the group, right? So there's a normals and there is a texture coordinate, right? So, but we don't say use material in here, right? We don't say use material in here. So that means it doesn't have a material, but how does it know how to do this kind of thing? So then there is a next group where we use material color map, and this part does use this kind of thing. So this one is really interesting. So how this stuff works. So here's the MTL. Yeah. So there is, I suppose this thing just creates a new material, right? So this thing just creates a new material. What is the KD directive? What is the KD directive? And there's also map KD. We'll need to learn all of that stuff, right? By the way, what is that? So it's from the website. It's the website of the creators of this entire thing. Thousands of completely free game assets for you to use? Free? Damn. That's a lot of different assets, and all that is for free. I can use that? Is my... Yeah, okay. So I can just download that, right? So I can donate, right? So that's obviously they should be paid. But then I can... That's actually super cool. And it's just like, why is that all of it for free? What is this? Huh. Kenny is very based. Yeah, it is kind of based. So I suppose I'm gonna just link them in the description as well. I'm not sure if I'm gonna use these assets in the final game, but I kind of want to use them as just like a placeholders, right? And see how, you know, how they're gonna look like. So just to have something to start from. It's Europe. Yeah. I heard that in Europe they're all communists. That's why it is all for free. So, cheers, by the way. But anyways, I heard that from Americans, right? So Americans call a communism anything where government is even mildly involved. just like mildly. That's already communism. That's the communism. The government overreach. The government. Anyways, so yeah, we need to learn what all of these things mean, right? So with KD and map KD and stuff like that. They're very good for prototyping. He always have sounds and UI stuff. Yeah, so at least like it has already like trees. So one of the things like I want to see is just like I want to make a forest, for instance, right? So how the forest is going to look like. I can just like throw it around, prototype it super quick, and just like, yeah, so have some sort of like a mock-up of a game. So having ID cards is for Americans is a communism. Yeah, everything is a communism. Everything is a communism. Everything. Everything I don't like is literally communism. Literally. So what we're gonna do in here? So we need to learn about this format. So MTL files. I suppose MTL is the material files, right? So MTL files, reference materials. Okay, that's cool. So I'm using this article a lot. So I suppose one of the things I want to do in here is maybe I'll already give it in the description if I could complete it. So materials that describe the visual aspect of the polygons are stored in both external MTL files. More than one external MTL material file may be referenced from within the OBJ file. The MTL file may contain one or more named material definitions. Okay, MTL lib, external MTL file name. So yeah, one materials. Okay. This tag specifies the material name for the element following it. The material name matches the named material definition in the external MTL file. Okay, sure. Oh, this thing has to be used in OBJ file, if I'm not mistaken. So here is the shovel OBJ. Yeah, so I'm just using that. And then I do use MTL, whatever. Okay. So this tag specifies the material name for the element following it. The material name matches a named material definition in an external MTL file. So yeah, material name. Named objects and polygon groups are specified with the following tags. Smoothing, is that it? You're gonna give me more information about material? Okay, material template library. So the material template library format MTL file is a companion file format to OBJ, also defined by that. Well, I mean, I already figured that out. Thank you so much. It describes surface shading, material properties of the object within one or more OBJ files. The OBJ file referenced one or more MTL files from the reference. Well, it's all obvious, right? So just give me definitions. Okay, so this is what we're talking about. A single MTL file may define multiple materials. Materials are defined one after another in the file, each starting with a new MTL command. Okay, so that's understandable. So the ambient color of the material is declared with KA. Oh, ambient, so it's basically the Phong model, right? So there's an ambient color, there's a diffusion color, and there's a spec. Okay, KA, KD, and KS. Right, so and KD is a diffuse color. Damn, okay, so this is actually kind of useful. So do we need to introduce the notion of that, of the material into our model? Right, so this is a diffuse color. Aha, and a diffuse color is white. So I suppose, this one is interesting, but anyway. So the specular color, blah, 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 and specular exponents. All right. So materials can be transparent. We don't really do transparency. Okay. So they don't really. Okay. So here is the map KD. The diffuse texture map. Most of the time it will be the same as ambient texture map. All right. But what is it? Diffuse texture map. Diffuse texture map. I suppose what that means is when you're reaching for a diffuse color, right, so just take a pixel from this texture map. I suppose that's what it means, right? Which is kind of interesting, so that means you can have separate textures for diffuse and specular. Right, for diffuse and yeah, exactly. So this is what I also think. So this multiply. So which means that maybe I do have to multiply it like by white color if, yeah, so this one is interesting. So this is probably why, this is probably why there was like a black parts. This is probably why there were black parts. Multiply by white does nothing though. Yeah, exactly. Different textures map is normal. Yeah, so do we multiply or do we add them together? Maybe we add them together. Yeah. But anyways, so, and what I wanted to say is that for specular map, you can have a texture which will essentially give you a reflection. Do I understand that correctly? Right, because through the specular map, you can have a very specific reflection on the on your object, because that's what it feels like. Is alpha relevant in the material? I don't know. As far as I know, alpha does not necessarily mean transparency. It's just like, depending on the context, it actually can mean different things. Black no specular, white most specular. But in this case, we're doing diffusion. You can have some parts of the texture have a specular and others not, so you can have materials that only sometimes specular. Okay, whatever. All right. So I kind of understand what this stuff means, but I'm still not sure what the fuck is that. Right. So I have some group in here. And there is no material attached to the group. There's no material attached to the group. Or is there? So, for example, I have two groups which are called shovel. But if in the second one I use material, does that automatically apply to that one above without any use material? And why are they called the same thing? Are they considered the same group? Right, since they have the same name. Right, so I'm not quite sure how to interpret that. I'm really not sure how to interpret that. But anyway, so let me try to do something, right? So here is that. So OPT color map. So here's the OPT color map. And we can try to multiply it by white color, or maybe add the white color. Or we can use this as the main color and we can just sort of mix it in. That's one thing we can do. So let me find place model, right? Let me find place model, and here it is, and I'm gonna just set the white color in here like that. So if I just set this thing like so, and run it one more time, it has to be like completely white. So so this one is completely white, which is understandable. All right. So then, oh, wait a second, I just realized something. Why all of that could be black? It is because I have to invert the texture coordinate wise. You know why? Because the OpenGL coordinate system. So yeah, didn't think about that. So how can we invert all that stuff? So what I can do in here is maybe subtract V to F, and this has to be something like that. But I mean, that will negate it completely. So fuck. How can I do that very easily? I don't wanna, well, I mean, I can always do some shit like this is annoying. This is really, really annoying, because then I'll have to convert it to integers. That just means I have to come up with a separate name. So essentially what I want to have is just some sort of a parameter in here, right? So then I can do y, and I can invert that specific y, but I want to leave the x as is. Right, I want to leave x as is. So 1 minus y coordinate. Thank you, Sherlock. You're so smart. Holy shit, bro. Bro, this is so fucking smart. Holy shit. So just subtract y from, yeah, I want to do that using the vector operations. What's the easiest way to do that using vector operations? Because if I do something like this, right, so 0 1 q, it's going to also negate x, which is not what I want, which is also gonna negate x, and it's just like fucking stupid. How do I freaking do that? I don't fucking know. I can multiply. It's so dumb. I can multiply it by 1 minus, like minus 1 1. Alright, so minus 1 1. I fucking hate it. Okay, chat. I'm gonna put subscribers on. Okay. What's gonna be the best way to do that? Let me think. Multiplication. I can maybe create a function, by the way. So something like flip vert, something like v to f. Flip vert. So this is multiplication. Yeah. Flip vert v to f. Something like that. Flip vert v to f, and this one is going to be something like this. So that will probably make it a little bit better. Okay, so v to f and v to f v, and so v y. And name does not fully reflect what I want from it, so I really hate this operation, honestly. Right, so because name doesn't encode that this has to be 1. Flip vertically normalized, something like that, right? So flip vertically, flip vertically normalized, patch texture coordinate in the input. This is one way to do that, but we'll probably do that a little bit later. Unused Q, yeah, whatever. Okay, so this is the Q. Okay. Okay, got it. Dab, dab, dab. And I think that's what it's supposed to be. Was it really blue, by the way, in the original image? Huh. I didn't think it was blue. I think it was blue. It was kind of a grayish, not grayish, but brownish in our original version. But in the Blender, I think it was blue. I think, kind of, sorta. Let's actually try to import it one more time. Let's try to import it one more time. So let's go here. And I'll have to go here again. So where is it? I might as well just, you know, navigate there manually. Who cares? Who cares? Okay, so here is the assets, OBGs. We're gonna put that in here. So here is the stuff. Can't see shit in this mist. Okay, so I remember that. So maybe rendering or texture paint. Fucky wacky, fucky wacky. Okay, so but the these parts I think are kind of fine. I feel like they are kind of fine. Yeah, let me actually see. So let me actually see. So they kind of are, but what's up with the x coordinates? I think they don't have a texture color, that's why they're black. They're not black anymore! Do you see what's going on the screen? So they're white. Okay. BGR, maybe BGR, GBR, blah 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 blah. Okay. So yeah, but this fuck. I completely forgot. I completely fucking forgot that if you take a look at the definition of yeah. What's funny is that yeah, anyways, I should have probably not in assets done that thing. Let's bring back this. All right, so let's do it one more time. Let's go through the compilation errors. Here's that stuff, and yeah, so this one we take the pointer to all of these things, right? Pointer to all of these things, and actually it has to be a caller, and then we are dereferencing the whole thing. We are just dereferencing the whole thing, and yeah, so let me fucking see. So, and in here I'm just taking this whole thing, casting it to the caller, and just doing it like that. So that's probably what's going on here, but not 100% sure. No, it was not it, and it shouldn't be, in my opinion. Actually, it shouldn't be. But why? So we can try to maybe like swap the coordinates and stuff like that. Why not? You're still using RGBA data as BGR. Where do I still use that? Place model. Place model. Root. Where's the place model? Okay. I'm simply copying things. Why? Okay, chat is asking too many stupid questions. Subscribe not. All right. So what we have to do in here. Yeah, maybe I do need to reconsider that. So I'm actually surprised. So in the overlay, I fill the image. Where do I use the image though? I use it for the cursor. And the cursor is actually completely black. That's why maybe the different order of the components never mattered. The different order of the components never mattered. Right? So that's why I was confused, because it was never a problem. But it was never a problem because I never really used any like this kind of stuff for anything serious anyway. Okay. So place model OPT, and that means we need to swizzle that stuff around. Which is more annoying than I expected. Okay, so I feel like we should just always render in RGBA32, and swizzling must be the problem of the platform that is bleeding the scene onto the screen. Right, so I made a stupid mistake even in the first episode of this series, where I just did BGRI as a quick hack, but now it bites me back. So it really has to be the responsibility outside of the game. It's crazy how long something can have work without noticing it sometimes. Exactly. So yeah, and what we need to do in here is to swap R and B, right? So because that's what it is. So if I take a look, yeah, so it's basically swap R and B. I think the easiest thing to do right now is just like something like this. R and C1B, and this is gonna be, what is that? U int T. So let's do that for 2 as well, and let's do that for 3 as well. So at least we discovered that there is a flow with this kind of approach, and yeah, okay, so that seems to be working. So congratulations, absolute budgeting. So subscribers off. All right, but I mean, it's kind of like it uses solid colors right now, which is not exactly what we want, right? So this is definitely not what we want. All right. So let's try to enable the color interpolation, right? So let's try to enable color interpolation and see how it's gonna work. It's probably not going to work at all as of right now, right? So let me see. Okay, so some things do not compile because I haven't looked into this stuff for a while, for a little while. So here is the Z's. So there is the chunks and there is the Z's, and we have to interpolate the Z. Okay, can I query replace V 1 to 3 dot Z and just replace it with one of those things? So Z1, boom. So I think that may work. And so now it complains about some other things. So this is going to be U1. So we have U, it's a barycentric coordinates, by the way, so it's just a U. And I suppose I can replace U1 with UX, U2 with UY, and plus U3 with UZ. All right. So it is smooth now. Look at that. It's pretty smooth, I think. Look at this shovel. Look at this mother flipping shovel. Can you see it? It's a very cool shovel. So yes, and in terms of FPS, look at that. It's not that slow. It is not that slow. So maybe I'll just enable it. So what is the diffusion? Okay, so I disable diffusion. Without the diffusion, you can clearly see how it is gradientish and stuff like that. So this is kind of cool. With the diffusion, it adds additional thing in here. Though, it's kind of interesting. I think for the diffusion, we kind of do a really weird thing. I think diffusion doesn't really work. Yeah. So this looks better than with the lighting, I think. Or maybe it's hard to tell, honestly. Is there a gradient in here? Smaller FPS hit than the text render. Yeah, exactly. With the text rendering, is just like it's pretty significant FPS hit. But here's the thing. So they're all using the same texture map, which means theoretically, I can try to load more different things in here. It's a bigger shot. It's actually rather small. Look at that. It's just like I zoomed in. I just like with the camera. Right, but it's by itself. It's rather small. Without the fog, it actually looks cool. Yeah, and with the specula, look at the specula. Look at that. Oh, very cool. Yeah, here's also fog. So let's try to add more different objects in there. Let's try to add more different objects in there. So this is the assets, OBG, Kenny. Okay, so let me. So where was that? That was somewhere in the tasks, right? So that was somewhere in the tasks. And let's go into this specific task. So this is the assets, Babajis. So what do we want in here? Which models? Oh, there's even different formats, GLB and stuff like that. Bench. Let's give bench a try. So they use basically the same materials and stuff, right? If I understand correctly. So this is basically the same materials. Assets C. Okay, so this is that, and here is the shovel, and we need to put a bench in here. Okay, so here is the bench. Okay, so let's try to run the whole thing. Yep, so I mean, it compiled, but we don't really use it anywhere yet. So yeah, I can say that this is probably fine. And I feel like I want to actually just enable the interpolation between the colors, because I don't think it's that bad. I don't think it's that bad in terms of performance, so we can just like do that. So adding textures, so this particular task is related to this. Okay, textures okay, so it's just add textures. All right, just add textures. So I'm gonna just do that and maybe remove this entire thing. Yeah. It's not that big of a thing, but I mean, all of these operations become kind of slow. So, but maybe optimizer can optimize all that stuff. After all, this is the most expensive operation of the renderer, right? So adding more things in here is kind of dangerous, right? So because we're doing this kind of stuff for each individual pixel, and we're kind of heavily relying on the optimizer and auto vectorizing, which we shouldn't, but I mean, right now we kind of do. So tree, we can also add tree. So we should probably actually, you know, render several objects. So let's go into the root C. Well, I mean, place. Where's the shovel? Right. So here's the shovel. So then in here we can do bench, but we kind of want to put that slightly in different positions. So we can do vector to f add, and in terms of x, let's just add v to f f1. Right, so in the position it's actually 3, so that means it has to be 3f. I want to actually only add the x, right? So let's also only add the x in here. So I just want to put them side by side. So and yeah, look. It's kind of surprising that it fucking just works. That is budgeting, I guess? That's so cool. What the fuck? Wait. That is insanely cool. Holy fuck. Okay, okay. So let's actually add more things in there then. So yeah. Okay. So somebody suggested, Murky, you suggested to add tree. Oh, so there's also candle, but let's go with the tree. There's no trees. Fuck. There's no trees in here, so there's a trunk. Yeah, let's add the trunk. So this is the assets. So this is a Babaji. Alright, so let's put the trunk. So it's, I hope it's not the trunk from the elephant or something like that. But yeah. Maybe at this point it makes sense for me to just copy all of them in there. Pine or some, maybe it is called Pine or something. Yeah, so OBJ format. So yeah, that's a lot of different things. Yeah, let's actually copy everything in here. Yeah. So, and there's, in terms of texture, there's only this thing. Yeah, so I'm copying all of that. Creek to large. Fence. Grave. That's a lot of like things to prototype from, I think. So let's copy paste. All right. And Pine. There is in fact Pine. Okay. So now src build. So bench. I should be able to just quickly replace bench with Pine. And with the main game, so this is road C, this one is going to be basically 2, and this is just a Pine. I can always even put them into an array of different models and just like iterate them and stuff like that. Right, so there's a lot of things in here, and okay. Honestly, this is amazing. This is a very cool style. I really like this style. And I mean, already we have a little bit of a performance hit from all of that stuff. So that means we have an opportunity to optimize all this stuff. But yeah. This is basically, by the way, the debugging view for the chunked renderer, right? So because we don't render the things triangle by triangle anymore, I finally implemented the chunked renderer, right? So these are the chunks. They're overlapping, but yeah. And by the way, we don't even parallelize them yet, right? So one of the ideas I had is that basically split the screen into n parts for each individual thread, and then take the chunks and place the chunks in separate bins for each individual thread. Oh yeah, so there's a little bit of a bitrate stuff. I think I can disable chunking, right? So here's the chunking and disable chunking, and you can clearly see that for all of these big walls, it renders the huge triangles, right? So it renders the huge triangles. As soon as you enable chunking, it starts splitting them into separate chunks, right? And usually it kind of improves the FPS, right? So as you can see, it goes down, and then you do the chunking and it goes up, right? But let's not actually do that. Anyways, so here is the stuff. Might as well actually put a gap between them, which is like 2 chunks, yeah. Chunked renderer. So here are different things. So we can try to, maybe it's too much. Yeah. Maybe we can try to take a look at some other things. So pine, pumpkin, trunk. Did I do? Let's try take a look at the trunk. I'm really curious what is the trunk. Honestly, we can just like load all of them in there, an entire thing, and just iterate through all of them. We can kind of theoretically do that. So this is a trunk, and this is a 3. Oh, it's just a. Okay. No, it looks okay. Would be kind of interesting to know how many like triangles it is rendering right now, but yeah. All right, I think I kind of achieved what I wanted to achieve already. Am I streaming for 1.5 of an hour? What else is left to do in here? So how big is the assets? 2 megabytes, right? So we added like 4 additional models, and it's like 4 megabytes plus color map as well. I wonder how we'll approach saving individual scenes, just in a code or some custom format with built-in editor. Not quite sure, actually. Not quite sure. So I may start with just in the code, right? So we can start from the bottom up. We can start just in the code, and in the code, it will probably evolve into a specific structure, and then we can map that structure to some sort of a format. Right, so yeah, so but maybe there should be, we could have used some formats for the scenes, existing scenes, so it's easier for me to edit these scenes. So yeah, can you just use something in a Blender? Frostum colon is not yet, not yet. Do you have ideas for the gameplay? Kind of like rough ideas, but I need to try them out. We need to try them out. So yeah, handling MTL files is rather interesting. So texture map becomes an asset. It's an image asset, which means now somehow I have to describe dependencies between different kinds of assets, right? So I have a model loads an MTL file, an MTL file loads an image file, and that image file has to be put as an additional asset into the asset pack. So now, you know, loading a model, like packing the model asset can trigger packing an image asset, and they're somehow related. That is rather interesting thing, actually. That is rather interesting thing. Does CPU reservoir has instance rendering if basically you load model into memory? Instance rendering. So I don't know what instance rendering has to do in software rendering. It makes sense in OpenGL, but this is not OpenGL. This is CPU rendering. I don't really know. I don't really know what you mean. Okay. So I suppose I'm not gonna stream for too long today, right? So 1.5 of an hour is enough. Plus my sleeping schedule is a little bit fucked. So I think I'm gonna call it. Yeah, I'm gonna call it a day. So I achieved what I wanted to achieve. I wanted to just like bring all of these models into the game. They are in the game, so I guess it's an absolute Bajonic moment. Instance basically only useful because you don't want to send the same model to the GPU. Yeah, exactly. So this question doesn't make any sense in the context of what we are doing, right? So anyways, I guess that's it for today. Thanks everyone who's watching right now. Really appreciate that. Have a good one, and I see you all on the next recreation program session with Ahu Amista Azuzin. Let me close the thing. Okay, love you all. Mwah.